Hi, in this video, I will be showing you problem number 55 of chapter 4, section 4 from the practice exam. Find the limit. Use the L'Hopital rule if appropriate. If there is a more elementary method, consider using it. Limit as x approaching infinity, 7x minus ln x. As we normally do, we will plug and play into the function, the limit value. So it's 7 times infinity minus ln of infinity. Ln of infinity would be infinity. So it's infinity minus infinity, which is indeterminate. In this case, it's an indeterminate difference. So in this case, we are going to apply a different technique. We can apply L'Hopital rule only when it becomes a quotient. So we will simplify 7x minus ln x and write as a product. That is x times 7 minus ln x over x. So if you distribute, you will see x times 7, which is 7x, x times ln x over x, that will be ln x. So now, as x approaching infinity, we notice that this part is already tending to be infinity. This part is tending to be infinity. And the 7 stays as 7, whatever happens to x, whatever the limit of x is. But we can consider this expression ln x over x, and we find out what the limit is. And then we can get back to this step and apply the limit. So before we apply the limit as x approaching infinity of 7x minus ln x, we are going to write that as a product, limit as x approaching infinity of x times 7 minus ln x over x. And we already know x is approaching infinity, and we are going to consider the one in the blue color, which is ln x over x. Then we find out what that limit is as x approaching infinity. So limit as x approaching infinity of ln x over x. If you apply the limit directly, it is ln infinity over infinity, which is again infinity over infinity, which is an indeterminate quantity, but indeterminate quotient in this case. Now we can very well apply the L'Hopital rule here. Limit as x approaching infinity, ln x over x. Applying L'Hopital rule, the limit is x approaching infinity. Derivative of ln x, derivative of the numerator over derivative of the denominator, which is limit as x approaching infinity. Derivative of ln x is 1 over x. Derivative of x, which is 1. So it is pretty much 1 over x. The limit as x approaching infinity of 1 over x is 1 over a very large number. So that is going to be 0. So we notice that in step 1, the limit of ln x over x is actually 0. So now getting back to the original step 1, so limit as x approaching infinity, 7x minus ln x. This is from step 1, which is limit as x approaching infinity of x times 7 minus ln x over x. So which is nothing but limit of x and then times limit as x approaching infinity of 7 minus ln x over x. What we are doing is we are distributing the limit to this product. We have a product here, so we are finding the limit of x times the limit of 7 minus ln x over x. So which will be limit of x is x approaching infinity. This part is going to be infinity. The other part, limit of 7, which is 7. Limit of ln x over x from what we just proved is equal to 0. So it is infinity times 7, which is again infinity. So keep in mind, whenever we have indeterminate difference or indeterminate power, something different from indeterminate quotient, you have to bring the problem to one of quotient and then apply L'Hopital rule. Hope this video helps.